There we go. Now I'm recording. Okay. So, ooh, Patrick has a link. Oh, I'm not sharing my screen, so it's all very interesting to me, but it's not very interesting for you guys. Hold on. Let's see. Share screen, and I want to share this one, and then I want to go back to here, and it says turn on Linux and make sure you're signed in. Open your system settings. Scroll down to Linux beta and select turn on. So there's a version called Miniconda. And you're supposed to download that. And I guess it's the Linux, I guess it would be one of these two, because we're using 3 point something. So you either have 32-bit or 64-bit. And then I don't know. So what's in here? Let me just download one of these really quick. So I'll just hit save file. And we'll figure out what's in here. Oh, it's completed already. Yeah, and then I can't open it, unfortunately. Try that. Yeah, I can't open it. But anyway, there's a link here. Where'd it go? Oh, damn it, I closed it. So what about Python sculpt? Run. The problem is we may not be able to save it, so we may not have the idle shell here. And I clicked run. Oh, clear. Okay, so I guess we could, yeah, you could copy and paste the code, I guess. So having said that, you Chrome people are kind of on your own. You're not on your own. What's this, online Python? Let's try that one. Oh, look. The sum of 4 and 5 is 9. Okay, so this kind of works. So there's an online Python, online-python.com, and you should be able to write code, I think. So let's do this. Let me just type something. Print. Oh, run. Hello. Yeah, so it kind of works. So yeah, so there's a couple of options here. I like this one. But again, we're going to need to be able to, what am I doing? We're going to be able to need to, you're going to have to send me the code. So the idle environment is really what I'm looking for. But you can, I guess if it works, copy and paste the code because the code does stay, it doesn't go away. So when you need to send me a program or I need to look at it. So we'll see how that works out. So there's some options for you. So there you go. So, are there any other questions? What time is it?
Professor, do you know why they replaced Visual Basic?
Yeah. You want me to tell you?
Yeah, I'm just curious.
Sure. No, the reason that we don't use Visual Basic anymore is the doctorate type professors didn't think it was powerful enough, didn't think it was modern enough. So we changed. It was just an opinion of, or a group consensus. And unfortunately, I was the one teaching it. And I was the only one that didn't want to change. But I don't know if that was because I was being lazy or not. No, no, it wasn't. I liked building the user interface. So it's just the way it happened. Python is used by a lot of universities as an introduction to programming, introduction to coding, basic computer science classes. So Visual Basic used to be used a lot also, but it's kind of fallen out of favor. It's just kind of a trendy thing. I liked it for a couple of reasons, in particular that we can build programs that are freestanding, that look like, or at least behave like real programs. But it is what it is. They saw the opportunity to change the content of the class when the class kind of changed when we went to semesters. So that's kind of why it happened. So remember, when's the homework due? Tuesday? Is that right? Nobody knows. I don't know when the homework's due. Some of you have already done it. I have not looked at them. I have got some emails, but I haven't looked at them. Actually, in particular, I will probably look at and try to do some grading this weekend. So there you go. So so if you turn it in early, you'll see in your grade book at some point this weekend a grade. And by the way, I'm going to grade on I'm going to give you points for stuff. So this one is worth 15 points. So it'll be out of 15. And you probably get 15 points unless you really screw it up. So there you go. So let's take a look at, or let's talk about something computer science related. And what I want to talk about is I want to talk about binary and the binary numbering system. And I want to talk about bits and bytes because we really have to understand how a computer works. So what is a computer, he asked. I'm going to do a whiteboard. What is a computer? Define what a computer is. Define anything. What's a computer? We know kind of what it looks like.
So
There are 10 kinds of people.
A computer would be a system. It's like a collective system where, sorry, I just got a really bad headache today.
Yeah, no, I read it. I read in the chat room you did. I'm sorry that I hope you feel better.
Yeah. Yeah, that's what I get for trying to fast. Anyway, sorry. So like a computer is a system where it could be, you know, it could do a lot of tasks. That is very vague. I'm so sorry.
No, it's okay. Okay, so Valerie played, and she has a headache. So what's your guys' excuse? Play. And stop making jokes, Patrick. Although it is a good joke. I like that one. Okay, so it's a piece of a machine. See, we're starting to get a little bit closer to the actual answer. Part of that is okay. A computer isn't really a piece of something. It is self-contained, or it's like there might be, but you know, oh, I have to go use the computer, so let me go in the kitchen where the refrigerator is, because it's a part of the refrigerator. So it's not a piece of a machine, it is a machine, right? And what does the computer do? It's going to be a long morning. If I don't get any answers, it's already going to be a long morning. It has software. Does it? Does it have software? It has a power source. Oh, that's good. So we said it's a machine. I'm ignoring the chat room here really quickly. So it's a machine, and it needs, that's a C. And it needs power, right? So it's electronic. Okay, so let me look back over here. It runs applications. Computers mechanically or electronically, or we don't have to qualify that, actually. Process input and yield output. Yes, they were, Patrick. Patrick is full of useful information, or useless trivia, or useful trivia. I don't know. So it's an electronic machine that takes input and produces output. See, if we all play, we can kind of put together a definition. We can all answer it kind of together. I'll take bits and pieces of everybody's stuff. Now, it does not need hardware like a mouse or speakers. And by the way, if you are blind and you cannot see, can you use a computer? Yes, you can. So my point, Valerie, was, does it really need a monitor? For the rest of us dummies, it does. Those of us that can see, I've had a few blind students, and I used to teach a web page class on creating web pages, and I remember I had a blind student in that class, and he actually created some very good looking web pages, even though he couldn't see them. So I wouldn't know how to use a computer without a monitor. But we really don't need speakers, and we don't need a mouse. You don't need, you can, if you just have a keyboard, you're fine. So we have to keep some of the peripheral stuff, at least be aware that a lot of the peripheral stuff isn't really necessary. But it's much more convenient to have some kind of pointing device, a touch screen or a mouse or the touchpad. You can navigate software using like the tab key and stuff, and probably you've done it, but it's a bit of a pain in the butt. But in a pinch, you can always do that. So let me go back here to, it's an electronic machine, so that means we have to plug it in, and it takes input, and it does something to it. or it lets us do something to it. Actually, it does the processing. We just tell it what to do. So it processes the input into output. Now, can you think of another machine that does the exact same thing that is not a computer? That probably most of you have had at some point in your lives. A phone. Does a phone take input and process it? Can we do stuff to it? Now, remember that a smartphone doesn't really count, because what is a smartphone? It's a mini computer, right? Calculator. Everybody likes calculator. It does do that, right? It does take input and it processes it, so it does the math that we want it to do to the input, and it creates output. So a calculator is actually a pretty good example, although not as good as mine. Nothing's ever as good as mine. So let me tell you what I was thinking of. Oops. I was thinking of a toaster. So a toaster takes input and processes it into output. So what is the input? Elizabeth's like, oh, what the hell are you talking about? A toaster is more fun. So the input here is what? Bread. Or what else can we input? You can do more than bread. Raw bread. I don't think I'd put raw bread in it. Isn't raw bread dough? I don't think you can bake in a toaster. Well, let's do a toaster. Think of a toaster as the kind that has the slots at the top. So you could do waffles or a bagel, or my favorite, toaster strudel. A bagel, bread, Lego my Eggo. Oh, those really super nasty toaster pancakes. Those are pretty horrible. You can input a metal object, like you could get a long knife that has a metal handle, and then you could poke around in there, and then the output would be a fried dummy. Electrocuted dummy, right? So what is the processing that happens in a toaster? You can't use heat, not toasting. We're trying to figure out what toasting consists of. And so what does a toaster do? We put in some input. So we put in our delicious toaster strudel, and it's not, or our Pop-Tart. Nobody said Pop-Tarts. What's wrong with you people? Pop-Tarts are delicious too. So we take our Pop-Tart and we put it into the slot, and we push down on the little lever. And then, we did say Pop-Tart? I didn't see it. That's because you have to talk to me, because I can't like focus and read at the same time. It's very difficult. So we put in our Pop-Tart, we make it go down into the slot, however, and then heat is applied, right? Heat is applied to whatever we put into the toaster. And then it pops back up again after a certain amount of time. And usually we can adjust the time. So that is our adjustment. How long does the heat get applied to it? And then at some point it goes bing, at least mine goes bing, and it pops back up and it turns off, and we have output. The output is if I do a Pop-Tart, is a warm Pop-Tart. That's probably a little bit brownish on the edges. If I put in a piece of floppy white bread, my output after heat has been applied is what we call toast. which hopefully is a crunchy, not too crunchy, piece of bread. Now, how is a toaster different from a computer? I haven't had enough coffee and I haven't had enough cigarettes this morning, so I'm a little bit weird. How is a toaster different from a computer? And it has to do with this part. Obviously, it has to do with you can't shove a Pop-Tart into a computer and it will not apply heat to it and you won't get a warm Pop-Tart out. I know that.
Okay, I got one.
Yeah.
So, obviously your thing, because, if you try to shove the Pop-Tart into the TV drive, you just ruined it. But the computer itself, it won't, it doesn't have, a heating up to cook food, but I'm pretty sure someone's programmed to do it. But, we're just doing it genuinely. And, I don't think you can program a toaster to write code for you.
Well, you can't program a computer to write code for you, but you do have the correct answer. So you can't write a Word document in your history paper using a toaster, right? Why? It doesn't have a monitor, it doesn't have a keyboard, but I'm really focusing on the processing element here. So the processing element is what I want you to think about. A toaster obviously can't run a program. And a computer cannot, and I don't care whether, I actually got a second-degree burn from a CPU, so you could cook on it theoretically, but it's not built for that. So what is different in the processing of input to output in a computer as opposed to a toaster?
Okay, I guess I'll go again. So I think the difference is when you're doing a toaster, you're getting something out, physical out of it, but when you're doing it at the computer, you're getting out something more digitally out of it.
Okay.
You don't get the physical process with a computer.
No, I get you. I understand, but what I'm trying to focus on processing. The word you can't really read because it's so sloppy, and the word that I've circled 1,000 times. How is the processing in a toaster different than the processing of a toaster as opposed to a computer? And the answer is not that the toaster is applying heat. Okay, it's a more theoretical question. And we were kind of getting close to it when Valerie said that a toaster, you can't do anything else with a toaster other than apply heat to your input. Right? That's it. That's what a toaster does. If you put in if I put in a piece of paper into the slot and it applies heat. Right? If I put a piece of bread, it applies heat. If I shove my watch in there, which I took off, it applies heat. Right? So it doesn't matter what the input is with a toaster. It's always going to apply heat to it. So how is that different from a computer? Other than a computer does not apply heat. And again, you have to think theoretically. So think in an
seems like a computer is dependent on the input for what output you get, while a toaster is going to give you the same output regardless.
Hold on. You're close, but what's the word that I have circled 1,000,000 times?
The process?
Yeah, and so you just told me that the output's dependent on the input, which is technically correct, but it's also incorrect because It's the processing that we need to focus on. So I'm going to circle this till all you can see is this thing. So you're really, really close. Come on, help him out, everybody.
The toaster only has one process, while the computer has you can do a lot of processes, I guess.
Processing.
Yeah, processing. Yeah.
Yeah. That is also correct, and we're getting even closer. So a toaster can do one thing, and a computer can do different things. And how do we get a computer to be able to process, to do different processes? So what is what's the thing that lets us work with input and create output? What's the thing that lets us process specific kind of stuff and do specific kinds of things to input to create output? No, it doesn't have anything to do with programming or the CPU. So, what's one kind of input and output? It is not the parts in it. The computer cannot interpret and analyze inputs. I guess it can. But we may have to manually do stuff. So let's say that I would like to process some, so let's say what kind of input can we do with a computer? What kinds of inputs are there? Maybe if we can get the inputs. I'm sorry?
Keystrokes.
Okay, yeah, but that's what kind of input would that be? What are we inputting when you're using keystrokes?
What if I'm not on my game today?
Okay, you guys in the chat room are way too complicated. And you should listen, ask Valerie a question, help her out. I said, what are you inputting when you're inputting using a keyboard? Text. Somebody got it finally. Text is one kind of input, right? And so if I input text, that's my input. What might I want to do to it? What might I want to process? What kind of processing might I want to do? I know it's early. You guys need more coffee. I might want to do word processing. That's exactly the question that I'm asking you. What is that? What might I want to do with words? To text. What might I want to do with text?
Construct sentences.
Do I need a computer in order to take text and construct sentences? The answer is no, you don't need one. You can have a pencil and a piece of paper, right?
Yeah.
Thank you, Ezra. Ezra said, make text bold. That is processing, right? I did something to the text. The input was the text. I typed up a document. And by the way, I created sentences and probably paragraphs even. That's how complicated I can get. And then I wanted to make something bold, so I did. And then Valerie said, you know what? It would look even better if we italicized that bold text. So I did. So the processing is really doing something to your input. So with text, for instance, what can we do? We can make stuff bold, we can italicize, and I'm not going to go down. We can change the font color, we can change the font size, we can change the font type, we can change the margins of the document, we can do all kinds of stuff, right? So there's all kinds of processing to create our output. But what dictates what what do I need if I want to input text and process it and create some output? What lets me do that?
The keyboard?
No. Okay, so it's like I'm saying, we're focusing on processing now. So what is it that lets me process text into output?
The application itself?
Yes, excellent. See, now we're starting to wake up and class is almost over, so that's fabulous. So yes, it's the program, right? The program. So if I want to process text, I would open up Microsoft Word. And the program lets me input text. It gives me a bunch of processing options. And then my output is, well, my finished document, the thing that it looks like, you know, I want it to look now. And then I save it. And so I have a file and I can print that out, etc. So what if I wanted to edit pictures? So I'm a photographer and I want to edit pictures. What would I do?
Use a picture program to edit pictures?
Yeah, so I would need a program that lets me edit photographs or pictures, right? So I know that Word has some capabilities with editing pictures, but really, if you're serious about editing photos, you wouldn't open it in Word and then edit it, right? You would have a different program, and that program would let you specifically edit photos. If I want to do, excuse me, if I want to record audio and then I want to edit that audio, I need a program that will let me do that. So a computer is different from a toaster in that a toaster is fixed. It is an input-output device. It takes some input, but the process is hardwired into the toaster. What it does is it applies heat. It can't cool it down. It can't, do anything else. It applies heat. And then you get an output, which is whatever your input was with heat applied to it. Whereas a computer is an input-output device, but we can input. And by the way, there are only 4 kinds of inputs or 4 kinds of information a computer can work with. Data. Text is one of them. Graphics and photographs, by the way, are in graphics because you can draw something. Like if I do this, that's considered a graphic. And I could theoretically edit that. The third one would be audio. And then the last one would be, if I have text, graphics, audio, what's the last one? Guess. Text,
Visual.
audio, I'm sorry? Say it again. I didn't hear.
Visual.
What do we call that?
Visual data.
Yeah, what is our graphics visual data?
It's like a camera.
What do you, okay, so you can record graphics with a camera. You're bouncing around it. The chat room is saying, somebody say it
Video.
out loud. Video, thank you. Video, so you're bouncing around it and you can't say visual because graphics are visual, right? So video. So those are really, the computers are relatively simple. There's only 4 kinds of input and 4 kinds of, well, there's only 4 kinds of things you can input: text, audio, video, and graphics. Those are the 4 things. And by the way, there are 4 kinds of output: text, audio, video, and graphics. So the kinds of processing that we do to stuff, or that we want to do to our input, is dictated by, whether I can do it or not, is dictated by if I have a program that lets me do that. So whoever said that computers are multifunction devices, they are. A toaster is limited to applying heat. That's the process. But
Yeah.
a computer is not limited to just applying heat to stuff. It's unique and limited, well, it's unique and different from one another, and its usefulness is dictated by the software that is installed on it. Does that make sense to everybody? Right,
I'd like to,
yeah, go ahead, Valerie.
sorry, I was the one that talked about the toaster. Like I said, theoretically you can make a toaster do anything, but at that point, is that really the toaster? But when you do a computer, you don't have to, modify it to do that stuff, because that's a part of the basic, command.
Well, I mean,
That's what
Valerie, if you take a toaster and you make it into a vacuum cleaner, I'm not sure you can even do that physically, but let's pretend that you could. It's no longer a toaster. It's something else. Okay, so we'll just pretend that all a toaster can do is, and by the way, I'm pretty handy, and I don't think I can take my toaster apart and make it something else. Okay, and I've built computers. I mean, I bought the pieces and put it together and built a computer, so, but it has a single function, and that function is limited to whatever it's built in to do. Whereas a computer is the people in your philosophy class would be wrong. I'm answering Sebastian, and he said we discussed that in my philosophy class, and some would say it is still a toaster. Yeah, but some would say that you all don't exist when I can't see you. You're all just figments of my imagination. So the one thing that a computer can't do is toast bread. And I don't care how hot your CPU it gets, and if you lay it on the desk and you put a piece of bread on it, it's not going to toast it to anybody's satisfaction. It is a crappy toaster no matter how you try to get it to toast bread. Okay, so it's easier to go spend $10 and buy a toaster, right? And then you get proper toast. So a computer, Alexa, toast my bread. That is funny. Alexa is also not a toaster. That's the first thing I'm going to do when we're done with classes. I'm going to go ask Alexa to toast my bread and see what she replies. So now, of course, there are toasters that are internet capable and that you can have toast bread from far away from your smartphone using the toaster app. I don't know why we would need to do that. So having said that, a computer is differentiated from one another. If there was only one model of computer and we all had the same computer and we all went out and bought one today and we're sitting here, in 6 months' time, all of our computers would be unique. And the unique thing would be that at that point in time, we would have installed software that meets our needs. So that fulfills the processes that I want to do. So if I want to edit photos, I would install a photo editing, like Photoshop or something. If I need to edit videos, I would have video editing software. I have some sound recording and editing software because that's what I did every once in a while, used to do. I guess I still do every once in a while when I have some time. I record things. And then I have software that will edit that. So not everybody has that. So computers are differentiated in what they can do by the software that is on them. And that's really very unique. And it's actually kind of the most important thing to understand about computers is that the software is that's why they're everywhere. There's software to keep track of inventory. There's software to keep track of, a payroll for a company. There's software to keep track of you know, your music collection. There's software on your computer. There's software to play music. There's software to play videos. So a computer is really very versatile. It can do pretty much anything. You can read a book, or yeah, right, you can read a book. Oh, it's a communication device. We plug it in and we're all logged into the internet all the time. And you can get information and look at it and read it and listen to it and watch it. Right, so computers can do everything except very specific things. But as far as text, audio, video, and graphics, they're fabulous. And by the way, numbers. If you want to do books, you know, you use Excel or you use Peachtree. You can do accounting. You want to do your taxes, you get a program like TurboTax, etc. Right, so that's a good example actually, because TurboTax will let you do your taxes for a particular year. Really, it's very limited. It's almost like a toaster. But if you want to do that and you want to use a computer, well, you have to go buy the software and install it on that computer. I can't do my taxes on this computer. TurboTax is not installed. But if I wanted to, I'd buy it and install it. And that adds another layer of capability to my computer. So computers are very powerful. And unfortunately, what I really wanted to talk about was what a computer is. And then the next part would be how it actually processes data. And so I'll probably talk about that during lab because we're done. So are there any questions or comments that you can tell me and not write me? There's a taco shell toaster.